Alright, welcome back, guys. Today it's Unit 1, Lesson 5, and we're going to learn a lot about inverse relations or inverse functions. So, without saying too much, let's go ahead and just get started on the math. So, we have this example here. The owner of a candy company they're creating a spherical container to hold their small chocolates. And they're trying to decide what size to make the sphere and how much value will the sphere hold based on its radius. And now everybody should know this formula. The volume of a sphere is given by the relationship V equals 4 over 3 pi r cubed. That is the volume formula for a sphere. We learned that in grade 10. So let's go ahead and look at what the example wants us to do. So how can you use this relationship to find the radius of any sphere based on a given value? So instead of using this formula, instead of giving us the radius, we're actually now just given the volume, and we want to we want to work backwards. So this is the whole point of having inverse functions. It's basically working backwards. So let's see how to do this. This leads us to example 1. Use a table of value and a graphical model to represent the relationship between the radius of a sphere and any given value. Let's go ahead and do that. So let's go ahead and write out a table of value. So so R in centimeter, and on the right we will have volume in cm cubed. Okay, let's go ahead and have that and extend this box. Okay, so and we have our major formula here, so pi r cubed. This is our big formula that we're going to be using here. So let's go ahead and do it. So at 0 centimeters in radius, we will have 0. 0, 0 is a pair. I think we're all clear on that, right? 0, 0 is a pair. And at 1, r equals to 1, what do we have? Right, we'll have 1 cubed times 4 over 3, so times pi times 4 over 3, so we will have 4.2. My calculations are correct. And then let's go ahead and look at 2. It will be 33.5. 3, it will be 113.1. And then 4, we'll have 268.1. You can do this. This is just plugging into a formula, right? This is very simple. We have always been able to do this. This is just a function. This is a function problem. This is why we took grade 11. So as a result, we're going to go ahead and graph it, which I have done here for you. So right here, that's not the graph. This is our graph, right? So we will have some value. So we have some value plots plotted down right here, and this is our graph that we use this value to plot. So we can see that radius is an independent variable and volume is the dependent variable. So we will have radius trying to explain any change in the volume that we have. That's how this graph works. That's how graph works. And we created this table values and we calculated the volume of the specific radius. And now we drew a scatter plot and then we graphed it together. Now we have this graph. So we have a graphical model now. We're done our example 1. Let's see how we're going to find the inverse. So how are we going to find the inverse? So when we want to find the inverse, we want to do the other way around. We want to obviously use the other way around. So instead of trying to find volume based on the radius, we want to find radius based on the volume. So what should we do to this whole to this chart that we made, to this little value chart? We should flip it around. So instead of having radius first, we should have volume in cm cubed, and then we should have radius in centimeters. This is how this is how we should have our chart. So now we still have 0, 0, that doesn't change. And then now we will have 4.21, and then 33.5, 2, 113.1, 3, we can repeat that. And let's go ahead and graph that, and let's see what's going to happen there. Because we are using a graphical model, so we want to add in as much visual elements as possible. Let's go ahead and have graph it out. All right, so I've got that right here. Oh, not that. I've got this. So look at this graph. So instead of having radius as the x-axis, we now have volume as the x-axis. So that means our volume is now our explanatory variable, and our radius is our the variable getting explained. So we switch. So basically, you could think, oh, we just switched the axis, and then now we have, we changed it around. So let's see, how does these two graphs really relate? Right? Let's go ahead and have a comparison. Why don't we put both of these graphs on the same plot to see what they compare? Right here we do. If now we just graph everything without any units and it's on the same graph, we can see that the red curve is actually a reflection of the blue curve, but not across an axis. Unlike we learned back in grade 11 or 10, we don't have to reflect over an axis anymore. We reflect through this line, the symmetrical line of y equals to x. This is reasonable because we're switching the x and y values, right? So the y is on the left, the x is on the on the bottom. So we switched it around. So the inverse was found by switching the independent and dependent variables in the table of values. And the independent and dependent variables can also be switched in the equation of the relation to actually find the equation of an inverse relation. So which is what we're gonna go ahead and do right now. So now we kind of seen right here. This first step was basically a graphical response. It's more of a visual way of learning it. Now we're gonna look at the very mathematical way. How are we gonna go ahead and prove this? What can we do? And obviously, this is really inefficient. When we have this value chart, we don't want to go ahead and graph out calculate out every single one of them, and at the end we're gonna have to flip them. That's kind of inefficient. What if we have a function that could just calculate it for us, right? So let's go ahead and just do this. So recall that the volume of a sphere was given at the very start. It's volume equals 4 over 3 pi r cubed. So let's go ahead and determine the equation of the inverse. Now we were kind of told about how to do this just a few seconds ago. I just told you guys. Why is this upside down? Okay, this is interesting. Let me go ahead and delete that. Let's go ahead and put a new one here. Wow, that's really small. Okay, here. Let's go ahead and do some mathematical calculations. So y equals 4 over 3 pi r cubed. So when a second ago I just told you guys we can find the equation by just flipping around the variables. Sounds simple, but you guys don't know how to do it. So basically, we're going to be isolating. We're going to be isolating r. So let's see. If we want to isolate r, what should we do? We should probably use my pen for this. This is much better with the pen. Let's go ahead and use a pen. Why not? So v is equal to 4 over 3 pi r cubed. Right? We got that down. So let's see what other parts do we have. We want to isolate for r. So if we want to isolate for r, so why don't we just go ahead and I don't know. Let's multiply v by 3 so we get rid of the fractions. So 3v is equal to 4 pi r cubed. And now obviously it would really make sense if you just, got rid of your 4. So let's go ahead and do 3 over 4v is equal to r cubed. Pi r cubed. Well, why don't we just divide the whole thing by 4 pi? Why don't we do that? So that's pretty simple. And then finally, we're just left with, our cube. So what do we do to get rid of the cube? Well, we just cube root it. So we cube root both sides. So 3, not working again. 3 cube root. This is a cube root. I think you guys know. It's been a good amount of time that you guys been stuck. Wow, why doesn't this work? Well, you guys get the point. So 3 and then cube root 3 over 4 pi v is equal to r. And now this is our inverse relationship. So let's go ahead and try to, let's plug anything in here. So what can we plug in? Let's plug in 113.1. See what do we get, just for fun. Okay, so let's do that. 113.113.1 times 3 divided by 4 divided by pi, we'll get around 27, and then cube root, which is basically to the power of 1 over 3. And then we'll get around 3. Okay, that makes sense. So our math is correct. This is indeed the inverse equation. So now we have some other problems that's going to be kind of related to what we're going to do, but not exactly the same problem anymore. So let's go ahead and do these problems. Oh, and also, just an interesting note. Let's go ahead and do this. Let's do some bonus park. Let's do some bonus questions. Where's my copy and paste? Wow, this is not what I want to copy and paste in. Okay, reflection. Let's go ahead and compare the domain and range of the function and its inverse. So let's look at this. Okay, well, we kind of can't do it. So what's the domain that we have for our original function? Well, it's just the regular function, right? It's a cubic function. There's just the domain is everything. I could put in anything I want, and I will get an actual value. So the domain is XER, and the y, since it's a cubic function, it goes from, it's positive cubic function. It goes from the Q3 to Q1. So y is all real numbers. And let's look at this. What does this say? We have the volume, and then we're equal to R. What can't we put in here? Well, let's think about it for a minute. There's pretty much nothing, right? Cube roots, they're on like square roots. You can actually put in any real number. So x is all real numbers. So let's talk about what are there? What about the y range? We look at it and we're like, if we can put any value in here, and this can be negative, so y is all real numbers. So the domain and range is basically the same. So, but let's look at this. Will an inverse function always be a function? So we want to know always. Will it always be? So let's think about it. These questions are for later, but we should take a look at them right now to just give us an idea of what's gonna happen. And then why is it reasonable to switch V and R? We already explained this, but I want to keep B in mind because we can't solve that right now. We don't know. We don't really know if it's always a function or not. Right now, it seems like it is, but maybe in the near future we will be able to find out that it isn't. Let's go ahead and look at this question, example 3. So we're gonna keep B in mind. Let's put B over here. Put that question over here. We're gonna keep B in mind. So given f of x is equal to x squared, let's find the inverse relation. So we know that they're now calling it a relation. So I don't know. That could be a hint to B, but I'm not sure, guys. Yeah. So let's go ahead and see this. We already learned plenty of ways to do this. So let's go ahead and just do the algebraic way. Just pretty light. So y equals to x squared. So all we gotta do is just switch the location, right? We just switch it. So I don't know. X is equal to, right? And now what do we have? Because we just switched position of the y. So we switched positions, right? This is what we did. Hope it makes sense. So we switched positions. Now x is equal to y squared. And now if we just want to isolate for y, so y is equal to plus minus square root of x. Right? We always want to add in the plus minus. So now let's compare the domain and range of the function with its inverse. So note that this is actually a piecewise function. There's two parts to this. There's two parts to this function, right? This is y could equals to positive square root of x, but y is also equal to negative square root of x. Right? These are two functions. Well, it's not technically piecewise, but it's two functions. You should keep that in mind. It's two different functions. So what are we gonna do when we have two functions? Let's just graph it out. So because when everything becomes clear when we graph it out. So I have the graph for you guys. And obviously you could do it the graphical way and just graph out the original one, reflect it about y equals to x. It works too. I mean, that's how it's supposed to work. So let's go ahead and look at this. So we have this this is positive x, the top red one. This is obviously positive square root of x, and under it is negative square root of x. I think that makes sense. So we could look at it. So what makes a function what makes a function function? Wow, what makes a function function? Well, it has to pass the vertical line test. Does this pass the vertical line test? It doesn't, right? It doesn't. So this is a relation, and no, it's calling it a relation. So anyways, let's go ahead and compare the domain just to get ourselves really, really, really convinced. So the domain of the original function is x equal to all real numbers, and y is greater or equal to 0. But now, when we have this inverse, we now have x is greater or equal to x is all real numbers, such as x equals x is greater or equal to 0, and y is now all real numbers. So what can we notice? We notice that the range and domain switch places. So instead of having x equals the all real number, we now have y equals the all real numbers. Right? This is incredible. And instead of having y being bounded, so y has to be greater than 0, we now have x has to be greater than 0. This makes sense. It's an inverse function. We're flipping everything around. So let's determine if the inverse relationship is also a function. Obviously, it's not, because it doesn't pass the vertical line test. Right? It can be split into the middle part to get two different functions, y equals x, y equals square root of x, and y equals to negative square root of x. But because it doesn't pass the vertical line test, it is not a function. It isn't a function. So the inverse function, what is it really useful for? It's really useful when you solve problems, particularly when you're given of the value of a dependent variable and you need to determine the value of the corresponding independent variable. So dependent variable is your y variable basically, and your independent variable is your x value. Hope that makes sense. Let's go ahead and do example 4. Lots of copy and pasting here. Let's do it just right under here, because I don't want to save some space. Delete that because we don't need it anymore. Okay, so let's look at this question. Selecting a strategy that involves an inverse relationship to solve a certain problem. Wow. So this is big. We can use inverse relationships. So archaeologists use models for the relationship between height and footprint length to determine the height of a person based on the length of the bones they discover. This is pretty big, because we could discover some random footprint out in, I don't know, Antarctica, and we could be like, oh wow, that's a huge footprint. This guy must be really tall. So, anyways, back to this. The relationship between height, h of x in centimeters, and footprint length in x in centimeters is given by h of x is equal to 1.1x plus 143.6. So use this relationship to predict the footprint length of a person who is 170 centimeters tall. So this should be easy peasy if you are just, you have some intuitive. So let's go ahead and do this. So obviously, since we now have the y value, we have h of x. What do we want to find? Well, we want to find x. We want to work backwards. Why is this upside down? This is getting impacted by inverse. It's inverse. It's just, wow, it's gone. Okay, it doesn't matter. I'll just do this by hand. When I will. H of x is equal to 1.9x plus 143.6. So we really can't do anything here. So let y equals to h of x. This is just purely algebraic. So y is equal to 1.1x plus 143.6. So now, let's go ahead and interchange x and y. So x is equal to 1.1y plus 143.6. So now after we interchange, we need to isolate. So x minus 143.6 is equal to 1.1y, right? And then we can go ahead and define this, divide through. So y is equal to x minus 143.6 divided by 1.1. Okay, that makes sense. You're like, that makes sense. That's right. So now, and this is actually equal to h of negative 1x, or the inverse of h of x, right? This is how we write the inverse. Right here. This is how we write it. H of negative 1x. This is how we write the inverse of a function. So the h of x, wow, h of x and his inverse, right? This is his inverse. Anyways, we didn't solve the problem, unfortunately. Let's go ahead and do that. So let's set this inverse function. So let's plug something in. So what do we plug in? Well, we plug in our value that we were given. So 170 degrees. Sorry, 170 centimeters. What am I saying? So we'll go ahead and have 170 minus 143.6 divided by 1.1. And for that, we'll get 24. So conclusion, therefore, a person is 170 centimeter tall may have a footprint length of around 24 centimeters, right? Now, this would have been really simple as well if you just sub h of x equal to 170, and then you do 170 minus 143.6 divided by 1.1. However, we have to include inverse in there, not because it's super good, because you need to know what inverse is, because it's a mathematical concept that's going to come in handy when you do some university math, or even in calculus. You will be taking differentiation of inverse functions, and you just need to know what they are. Not they aren't particularly useful, I would say, but they are. You need to understand them. They are a crucial concept. Let's go ahead and look at the summary for today. So in summary, and we have this definition and this thing that I just introduced now. So this is how you write an inverse function. So the inverse of f of x is denoted as f to the power of -1 of x. Function notation can only be used when the inverse is a function. So when we have the x squared thing, and we want to find the inverse of x squared, it's not a function, so we can't denote it like that. And the graph of the inverse function is a reflection in a line of y equals x. So you can see that here. Right here, the blue line and the red line and everything. Okay, so we need to know. Not all inverse relationships are functions, and we found out about this just a few seconds ago on the x squared example. The domain and or range of the original function may need to be restricted to ensure that the inverse of function is also a function. So looking back at this, we could limit it so that, we could only have the top part. So let's say y has to be greater than 0. So that we limit the range. So we have only one part. So now our inverse is a function. To find the inverse algebraically, write the function equation using y instead of f of x. Interchange x and y, and now solve for y. If AB represents a point on the graph f of x, then BA represents a point on the graph of the corresponding inverse function. Given a table of values or a graph of a function, the independent and dependent variables can be interchanged to get a table of values or a graph of the inverse relation. And the domain of a function is the range of its inverse. So we talked about this. So this is interchanging. And this is everything that we need to know. There is homework on page 43, 44, 45. I suggest you doing all the odd numbers as usual. Happy practicing and happy mathing. Hope you have a great day, guys.